Let us solve the exercise number 3 in the part B of R lab. In this exercise, we are supposed to write a R script to compute the regression equation of y on x from the given data. And they've said that we are supposed to predict the value of y when x is 7. And this is the equation that they have given. And we are supposed to create a linear regression model in this case. So let's go ahead and let's first solve this using R, and then we will come back and then try to solve it using the manual technique. So I'm going to go here to the R, click on the file and click on new R script. You can also do it by clicking on this down arrow here and then clicking R script. Both of them are same. And definitely after your work is done, click on save and save at the proper location. So the first one is we are supposed to get these vectors, that is x and y value. I'm going to copy them because I have already done that thing. If you notice over here, I've taken the values. So see, that is a 2, 3, 4, 5, 6, 7, and 11, and also 18 up to 15. I've taken these values. I'm going to just select this one, Control C from here, and just paste it on my script there. Otherwise, it's going to take slightly longer time for me to type those values. And what is the first thing that we are supposed to do is we are supposed to build the linear regression model, the linear regression model there. That is, we are supposed to get that linear model there. How do you get this linear model? So there is a way in which you can get it. See, at any time, if you are in trouble, this is for real life, not during the examination. In the examination, if you are in trouble, then you are on your own. Otherwise, if you really want to learn something on it, so if you want to clear all the things, the garbage that is being shown over here, what you can do is you can go here and then type CTRL plus CL to clear everything. That's the easiest way to clear the garbage on the other side. This is the place where it's going to show you the thing. So I'm going to press Control L. It's going to clear. Press the question mark and then search for what you want. So I'm going to use the linear model LM. I don't know what is that linear model LM. So I'm going to type LM and this function and press enter. On the other side, it's going to tell you what is that linear model all about. It will explain what is it all about. So for example, LM is used to fit the linear model, including multivariate and all the other things and so on and so forth. And they have given you what the individual things means in the entire equation. So this you follow it only during your free time when you really want to learn about the R script. You can always get the help on the other side by typing question mark, or you can also do that by typing help and then not here. Okay. At this prompt, you just type help and inside bracket type the function LM. So if I just type LM, it's going to show you what is it all about. Okay, this just for your information. So I'm going to just press Control L to clear them. So coming back to the one, I'm going to use that linear model LM here. Okay, and I'm going to store that model in a variable. Let me call it as fit. Okay, you can call it as the XY, not XY, that X is already there. Some other name, you can give any other name like model or anything. You can give some good name. I would just use this one, LM, and we are supposed to find the regression on L on the X value. So I'm going to use tilde X. So what does it means? I don't know whether they have told you about that thing. You just search to find out whether they have used that symbol somewhere. Okay. But I will not waste your time on showing you all what is there, because you can also read it at your leisure. So this, what it is going to do is it's going to predict the value of y on x. So this is what is the idea. So linear model of y on x, that is the meaning. So y on x just means to say that the tilde means it is on which one is on that. So y on x, we want to fit that model. And we are going to show what is that fit by using the print command. So you can use a print, or you can use cat command also, but let me use the print command because it's going to show you all the details of that, because your cat may not work in that way. So it's going to show you the value there. I'm going to plot the value of the x and y first. I'm going to plot that. So let me just plot. And this is not, I think, not really required for your examination. So I'm going to plot x, y, and I'm going to say the I want to connect them so that I'm going to say lines and between the x and y value. Also, I would like to show the regression. So how do I get that? When is I'm going to use the AB line, and the reason, if you are not getting anything, what is the AB line? You can just press the question mark and then type AB line here and then press enter. It's going to show you. Okay, add straight line to the plot, and you are going to get that thing. So AB line based on the fitness model that I have used, but I'm going to change the color of it, and uh, I'm going to say color. Where is it gone? Color is equal to, let me say, red. Okay. I have not completed the work here, so I'm going to just run this part. Let me just run this one. So I will run this one, and see the graph that you are going to get is when it is 2, x value is 2, y value is 18. So when x value is 2, y value is 18. So this you are going to get a plot here. Then when x is 4, y is 12. X is 4, y is 12. This is the one. Okay. So you notice that this is, let me just change the color as blue. This, if you connect it using the lines, that is what is the line. Okay. Plot will only draw the dots. Line will connect those lines there. Okay. Now what I'm doing is I'm trying to get the slope of that. So you can get the slope like this. Okay. But we are using the regression model. That model is going to fit the slope, which is perfect. So this is the slope that the model has fitted. So wherein some points are there, some points are on the one side, other points are on the other side. But on an average, this is the line that is passing through this curve. So we are getting a linear regression. That means to say that we are getting this linear model there, so that this value is there. So where is it going to touch and what is the value? So this is what is required. Remember, whenever you have a line, what is required by us is, in most of the time, we will find the slope of the line. So you know what is the meaning of saying slope of the line? When you draw like this and like this is going to be the slantedness is called as the slope of the line. And this is negative. Why this is negative is, as the value of x increases, the value of y is decreasing. The curve is coming. So initially the curve is at the top, and as the value of x increases, the curve is coming down and down and down. That means the curve is in the negative. It is moving in the negative way. Suppose if the curve was like this, as the value of x increases, y value also increases, curve would have gone like this. So then you would have got a positive slope here, but you are getting a negative slope here. So let us print that slope here. So I'm going to go here, and I'm going to have printed the value here. And if you notice, I think I've already printed it here. So you will notice that this is 3.14. So that is the slope of that particular curve. That is 3.14 is the value that you are getting. And now we got the model here. Now what is that we are supposed to do is we are supposed to, they are asked us to find what is the value of y when x is 7. So just looking at the curve, if I just zoom in, and if you just look at this curve, what they are asking is, suppose if this is 7, this is 7. Remember, I have to draw for the fitted. This is a fitted curve. This is the original curve. This is the one that is getting fitted. So if I just draw a line from here, assume that this is a straight line. Let me just draw some straight line. Okay. It's very difficult to draw. Roughly it is. Just assume that that's a line. And from this point, if I just draw a curve, you notice that it is slightly coming here. Okay. This maybe it is 9 here. Okay. It's 8, 9, 10. slightly closer to 9 it is coming. So this is 9. So this is 1, 2, 6, 7, 8, 9, and it is coming closer to 9. And so the intercept for the value x equal to 7, the value of y must be roughly 8.6 or something like that. So it should come in that order. So let me just go here and let us try to predict the value. So I'm going to say the value that I am interested. Let me just say n1 or x1, whatever you call it as. This is 7. Okay. How can I predict the value? So I'm going to predict the value and I'm going to store it in a variable p. To predict it, you have this predict. Okay. Again, I will not use it. Predict is a generic function to predict the value of a model. So that is it. Again, if you want really more help, you just put a question mark here and then say what is predict. Okay. And it's going to tell you what is the meaning of saying predicting. And so this is a generic function. It is doing and so on and so forth. So predict takes a few things. First one is the model. So the model that I have given the name as fit here, you can give it, I call it as model also, any variable name. Okay. And then we are supposed to give where I want to predict. That is called as a new data. So new data equal to, only problem with that is you have to supply a data frame for that. So you need to supply a data frame. How do you get to the data frame? You say data dot frame. You are familiar with that, data dot frame, and you say x value is n1. So this is the prediction that you're going to use it. And then finally, I'm going to use the cat function here just to show you the value of y. So I'm going to say value of y is, and I'm going to concatenate and I'm going to show the value of y. So this is the value of y. You can use x1, y1 or something like that. Use that one. So I'm going to just select this and I will go here and run it as a single source. And so roughly, I told you last time you are going to get the value as 8.6 or 8.7, somewhere closer to 9 you are going to get. And the value of this is, suppose if you really draw it here, so if you take this one as a 7, and if you try to draw it, it's going to come very close here. Closer to 9, you notice that this is 8, roughly closer to 9, and then you have the 10 values. So it is 8.66, 8.7 is the value. So this is what you are supposed to do it manually on your monitor, that is on your computer, and this thing is optional. There is no need to plot it and then show it. This is optional. If you want to show it, if you don't want, you just leave it. Nobody is asking you to plot that particular thing. I have just shown you that you can plot it and show it. You can just say that what is the fitness value, what is the slope of it, and then just predict the value and show it. Three lines. These 3 lines you can drop it from the actual the uh, the printout or whatever you say in your record book. You can drop that thing. If you want, you can use it. Now, how do you write it in your record book? In your record book, you have to manually do it. This part you have to write it. So R script, and you write that output, or you take the print out of that. It's up to you how it is done in your college. If some college write it and the other college they just take the printout. So in any case, the first part is the actual running of the program. So there are two parts over here. One is the running of the script that you are going to get 5 marks, and the actual solution you are going to get 7 marks. So you have to now show the actual calculation. How do you do the actual calculation? You have to know what is a coefficient of regression, that is a linear regression. What is the formula? It is nothing but the slope of a line. Okay. So how do you get it? Is n is the number of elements. So how many elements are there? You calculate 1, 2, 3, 4, 5, 6, 7, and so on. So you calculate how many elements are there. So totally 6 elements are there. 1, 2, 3, 4, 5, 6. N value is 6 here. So you are supposed to fit it in this n into summation xy. Just to zoom in for you. N into summation xy minus summation x into summation y divided by summation x square minus summation x whole square. This is the formula, and in order to fit this formula, you have to calculate all the values of this one. So first, let us calculate the value of the sum of x value, that is summation of x. You need this summation x and summation y. So you notice the summation x value you have to calculate. If you calculate the value of summation x and summation y. So how do you calculate? Add this value. So how to take your calculator and add it. 2 plus 4 plus 5 plus 6 plus 8 plus and so on. You're going to get this value. Similarly, y, you add it, 18 plus 12 plus 10 plus and so on. You get this value. So you got these two values. Now take this 2 x and square this x. So 2 square is going to be 4, 4 square is going to be 16, 5 square is going to be 25 and so on. Now you have to also get this summation x square whole square. So this x summation of x square you have to do it. So 2 plus 4 plus 16 plus 25 plus 34 or 36 plus 64 and so on. You get this value, summation x square full value, you are going to get it. Now you have to multiply x with y. So 18 into 2 happens to be 36. 4 into 12 happens to be 48 and so on so forth for all of them. Then you add them. You need this summation xy whole square. So the summation xy, for this you require this summation xy. So find the summation 36 plus 48 plus 50 plus and so on. So you calculate this value. So that is done there. Now let us substitute the value of them. So this I think this is not really required over here. So let's start with the n. N is 6 into summation. Let me use this one. N into summation xy. Summation xy is 293. This part minus summation x 36. So minus 36 into summation y 60. Got the 60 divided by summation x square. What is this? So summation. Where is this? So summation x square 266. 266. N value, n is there. N is 6. You calculated total number of elements 6 minus summation x whole square. So that is the you have this summation x 36 whole square. You do the calculation. You are going to get the slope minus 3.14. As what you got is this one. So you are going to get that thing. Now you have to predict that value. How do you predict the value? So to predict the value, you require the average, that is the mean value of x and mean value of y. And how do you get the mean value of x and y? What is the meaning of saying mean? Is sum divided by total number of elements. The total number of elements are 1, 2, 3, 4, 5, 6. So 36 divided by 6 is going to be 6. Similarly, sum all of them, 60 divided by 6 is going to be 10. So mean of x is 6 and mean of y is 10. Look at this formula. So this is the formula that you are supposed to use it. Y minus y bar is equal to the slope. This is slope. In your olden days, you used to call this one as m, slope of the straight line, m. Here we are calling it byx. Okay. Then x minus x bar. Okay. You take this. You want to predict the value of y, so you take this y bar onto the other side. So the minus sign becomes a plus and y bar is taken onto the other side. So this is your equation. Substitute the value of b. You have already got the value of b, b by x, that is the slope, minus 1.34. What is the value that need to be predicted? They have said that predict the value when x is equal to 7. So we are supposed to predict what is the value of x, what is the value of y when x is 7. So this x is 7 minus the average, that is the mean of x, which is already 6 here, and mean of y is 10. So minus 6 plus the mean of y. So you got it. Can do the calculation and you are going to get the value as 8.66. And this is what you are supposed to write on in your record book also. So that is required. That's all you need to do in this exercise. Thank you for your interest. We will meet again in the other exercise.